Hi everybody. So in this video, we're going to look at the parametric form for the equation of a parabola. And if you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So in example 1, we're given that the parabola has a general point with an x-coordinate of 80 squared and a y-coordinate of 2at. And we've been asked to show that from this parametric form, we can get the Cartesian form here. So if we know that x has a general point 80 squared, and that y has the general point 2at, then what we can do is we can make t the subject of this equation, and then we can substitute that value of t in terms of x into here. So then we'll have one equation involving the y and the t in terms of x. So if we begin by dividing both sides by a, then we'll get x over a will equal t squared. And then we can take the square root of both sides. So we get root of x over a will equal t. And then, like I said, we can substitute this value of t into here. So y will equal 2a times the square root of x over a. Now we can cancel out this square root by squaring all the terms in our equation. And we know that these will cancel. So we've got y squared. When we square the 2a, we get 4a squared. And this will cancel. So we've got x over a. Then you can see the square and the a will cancel. So we'll have y squared will equal 4a times x. So you can see then how these parametric coordinates give you the Cartesian equation for a parabola. And we need to be comfortable in working with both forms for a parabola, the parametric and the Cartesian. Okay, so let's look at example 2. So here we're told that our parabola has a general coordinates 6t squared and 12t. We've been asked to find the coordinates of a focus, which is in this point here, the equation of a directrix, in this line, and the Cartesian equation of a parabola. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back. So we know that x is equal to at squared, and we know that y is equal to 2at. And we're given in the question that x is also 6t squared. So we can easily see then that the value of a must be equal to 6. And this works with the y value as well. If y is 2at in its general form, and in the coordinate we're given 12t, well then you can see that the 2a must equal 12. So again, a must equal 6. So this will give us the coordinate of our focus, and this a value here will be 6. So the focus will be 6, 0. And then for the directrix, we'll have the equation x equals -6, or x plus 6 equals 0. And then for the equation of a parabola, we know the general Cartesian form is y squared equals 4ax. And if a equals 6, then this will be y squared equals 24x. So this will be the Cartesian form of a parabola. Okay? Let's try one more question. So in example 3, we're told that point P lies at the point AP squared 2AP, and that point Q lies at the point AQ squared 2AQ. And both of these are on the parabola y squared equals 4ax. We've been asked to show that this is the equation of a chord between P to Q. So again, do you want to try this question yourself? You can pause the video, and when you come back, you can check you're working with mine. Okay, so welcome back. So we can see that P to Q is a straight line. So we need the general equation for a straight line. And this is m multiplied by x minus x1 will equal y minus y1. So the first thing we need to do is to work out m, the gradient. And this will be the change in y divided by the change in x between the 2 points P and Q. So the change in y will be the difference between 2AP and 2AQ. So we'll have 2AP minus 2AQ. And the change in x will be the difference between AP squared and AQ squared. So this will be AP squared minus AQ squared. Now we can see at this point, on our numerator, we can factor out the 2a, and on the denominator, we can factor out the a. So we've got 2a multiplied by p minus q. Then for our denominator, we've got a lots of p squared minus q squared. And then we can factorize the p squared minus q squared using the difference of two squares. So we'll get 2 lots of p minus q over p plus q times p minus q. Then you can see that these two will cancel. So now we get 2 over p plus q as our gradient for m. And then we can substitute this into the equation for a straight line. Then we can use ap squared as our value for x1 and 2ap as our value for y1. And this is the equation of a straight line that we were asked to show here. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and a copy of a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.